This next example is going to be the exponential decay situation. So the concentration of a drug declines exponentially in the bloodstream in hours, has a half-life of 6 hours. So once you're given a particular drug, 6 hours later, you have half of that. You have half of that in your blood system. Suppose you have 100 milligrams of the drug in your system initially. So you're given a dose, 100 milligrams. 6 hours later, you would just have, 50, right? Because that's the half-life. Find the decay constant, rounded to 4 decimal places, and then you find the exponential function, Q of t, in general for t hours. So again, initially you have 100 milligrams. 6 hours later, you have half of that, which is 50. Okay, so 6 hours is how long it took for that 100 to become 50 milligrams. So we're going to solve this equation for K. I'm going to let you fill in some of those steps. I'm not going to do it all for you. You're going to end up getting K equals negative 0.1155. So, right, you're going to pause the video and you're going to make sure you work out the steps to get that answer. And that's the general formula for the quantity of the drug that's in the bloodstream at time t. Part B, if the effects of the drug will wear off when there's only 25 milligrams remaining in your bloodstream, when will you no longer feel any effect of the drug? So this means that we want to figure out when Q of t equals 25. Okay, so set the equation that you just found equal to 25 and solve for t. Okay, so I'll go ahead and work this one out for you since I skipped the other two. Divide both sides by 100. 25 over 100 is 0.25. Then you take the natural log of both sides, and you would end up getting the natural log of 0.25 equals negative 0.1155t. You divide both sides by the constant in front of t, and you end up getting an approximated value for t equal to about 12 hours. So 12 hours after the initial dose was given, you will not feel the effects of this drug anymore. So the steps that I just used to solve would be the same as the steps that I skipped over in the previous two examples. Part C, how fast is the drug decaying? How fast indicates a derivative. And so we want to figure out the derivative of Q with respect to t, and then we'll plug in the t value equal to 2 hours. So Q prime simplified will be negative 11.55 e to the negative 0.1155t. Okay, and again, we want to figure out what this value is. How quickly is the drug getting worked out of the bloodstream when t is equal to 2 hours. 2 hours later, how quickly is this reduced in the bloodstream? And that is about 7.25 hours. Whoops, sorry, I looked at the wrong number. Let's try that again. This is about negative 9.17, what are we, milligrams per hour? And so 2 hours after the drug was initially given, it's reduced by, it's going down at the rate of 9.17 milligrams per hour. All right, next question. When will the drug be decaying at the rate of 5 milligrams per hour? 5 milligrams per hour means that, once again, this is a rate. This is a rate. And so we're going to end up setting the derivative function, Q prime, equal to 5 is the rate, but it's decaying at that rate. So we're going to make it equal to negative 5 to indicate the fact that it's decaying. Make it negative, okay? Because this is going down at this particular time. Okay, so you set your Q prime function equal to negative 5. You solve for t. solve for t, dot, 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 you end up getting t equals 7.25 hours. So you're going to work that on your own, just like I would have done had we been meeting in the classroom. I would have given you some time to work that through, and then give you the answer once you had that opportunity. Okay, so I want you to pay attention to the homework assignment. Let me space that out for you so it doesn't run together. But the homework assignment over this first part of the exercises is given to you right here. Those are straight out of the book. Those are odds. You're going to work through those. You're going to make sure you've got enough practice before you continue with more examples.